This is Algebra Lesson 4.9. Student notes, it's called Which Method is Best? So we've been looking at solving systems of equations now for about a week, and we've learned how to do it using substitution, which is right here. We've learned how to do it using elimination. We've learned how to do it by drawing a graph, and we've also learned how to do it graphing using our calculator. So all those different ways are ways that we can solve. So what you need to do going forward is anytime you're given a system is to look over the equations, and it's kind of like a little puzzle. Just ask yourself what would be the best method, the most efficient one to use to solve the equations. So for this first example, we're going to do it in all four ways: substitution, elimination, graphing, and then graphing using a calculator. And then once we've done that, you can ask yourself the question, what would have been the easiest way to do it? So let's start with substitution. So on substitution, we see that y equals, remember for substitution, you either have to have y equals something or x equals something, and the second equation is already solved for y. So I'm going to plug x plus 1 in for y in the other equation. So we have 2x minus, and I'm going to put this in parentheses. It's very important that you use parentheses here. So we're substituting x plus 1 in for y equals 1. Now why is it so important to use parentheses? Because with this minus sign outside in front of it, it was minus y. Everything has to get subtracted, so we have to distribute the negative sign through the whole parentheses. So we have 2x minus x minus 1. You have to subtract everything. Now let's combine like terms right here. 2x minus x is 1x. Now we're going to add 1 to both sides, and you get x equals 2. Now once I know that x equals 2, let's plug that back in. I'm going to use the second equation. So we have y equals, instead of x plus 1, we're going to do 2 plus 1, and y equals 3. So according to this method, our solution is 2, 3. Now let's try it using elimination. Now remember, on elimination, we need to make sure everything is lined up. So I'm going to rearrange this equation. This second equation, I'm going to subtract x and move it over to the other side. So the first equation says 2x minus y equals 1. And then when I subtract x on the second equation, I have negative x plus y equals 1. So once I've rearranged, now I can use elimination. 2x minus 1x is x. The y's eliminate, and 1 plus 1 is 2. And then again, we'll put the 2 into the original equation, and we get y equals 3. So we got the same answer, which is a good thing because it should come out the same. Now let's do it using graphing. Now in order to use graphing, remember your equations need to be solved for y. Well, the second equation is solved for y. We have y equals x plus 1. But the first equation, 2x minus y equals 1. Well, we've got to subtract 2x. So we have negative y equals minus 2x plus 1. And then we have this minus sign hanging out here in the front. And when that happens, we need to change all the signs. That's our shortcut. We're dividing by negative 1. And what we do is change all the signs. So we have 2x minus 1. So let's go ahead and graph this. So I'll start with this equation right here. I'm going to graph the y-intercept, which is negative 1. And then you have a slope of 2. Let's put a 1 under it to make it a fraction. 2 over 1, 2 over 1, 2 over 1, and so forth. 2 over 1. Now let's try the other equation. It has a y-intercept of positive 1, and it has a slope of x, which would be 1. There's a 1 in front of that, so 1 over 1. So that's going to go up like this. Just go up by 1s. Kind of hard for me to do these on the iPad. And we're going to graph that line, and when we do, there's where they intersect right there, which is at, what do you know, 2, 3. Now, how about you do one last thing, put this into y1 in your calculator, 2x minus 1, and y2, put in x plus 1, hit your graph button, second trace 5, enter, 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 and you get 2, 3. Now, there's our solution, 2, 3. And what you have to do is think to yourself, what to you was the easiest way to solve that? Each one of these methods for this particular set of equations had its own issues. Like, for example, on substitution, you have to remember to distribute the negative sign, and if you didn't do that, you would get it wrong. For elimination, you had to rearrange the two equations to make sure the x's and the y's were lined up. On the third one, for graphing, you had to solve both equations for y so that you could graph it. And then, of course, you had to solve it for y to use your calculator as well. So, which method was the easiest for you? Write that down right here and explain why. I'm going to just say I think it was easiest on the calculator on this one, because once we solved for y, it was very easy. But maybe something different for you. You write down what was best for you. Okay, let's try the next set of equations. So we have these two equations, negative x plus 2y equals 6, and positive x plus 4y equals 24. Now what I want you to do is to think about each of the methods and ask yourself which one of these would work best for you. Which one do you think would be best? Think about that. I know which one I would use. For me, I would choose elimination for this one, because if you look right here, if we were to combine these equations, the x's would eliminate. We don't have to rearrange anything. Everything is already set up. The x's cancel. You get 6y equals 30. Divide by 6, y equals 5. Plug that puppy back into one of the equations. I'll put it into the second equation. X plus 4 times 5 equals 24. X plus 20 equals 24. Subtract 20. X equals 4. So there's our solution, 4, 5. It was very simple to do using elimination. Now, if you chose a different way, great. But I hope you got the right answer, 4, 5. You can use whatever method works best for you. Okay, let's go on to the back. Okay, on question number 3, we're going to have to set up the equations first and then try and figure out which method would be best. So let's look. A jar contains nickels and dimes. There's 20 coins in the jar, and the total value of the coins is $1.55. How many nickels and how many dimes are in the jar? So remember, your question is going to help you do your let statement. So we're trying to find out how many nickels and dimes. So we're going to let x equal nickels, y equal dimes. Now we have two equations to do. One has to deal with the number of coins in the jar, and the other one has to deal with the amount of money, the value. So if x is the number of nickels and y is the number of dimes, and there's 20 coins in the jar, then x plus y equals 20. Now for the value, each nickel is worth 5 cents, so 5 times x plus 10 cents times y equals $1.55. Now let's look over what we've got here. And you can ask yourself, what would be the best way to solve this? Well, I think there's, for me, there's one way that's the easiest, but there's a couple ways that are fairly easy. But the third way, I think, is the hardest. To me, the hardest one would be using the calculator, because you need to solve for y. And this equation right here might be a little tricky for you to solve for y, because you're going to have all these decimals, you're going to have to divide by a decimal, and you might have a little trouble doing that. So I think you should either use substitution or elimination. Now, if you wanted to use substitution, all you would have to do is subtract x, and you get y equals negative x plus 20, and then you could substitute that in, whoops, not there. You could substitute it in for the y right there and solve it. Now, the other thing you could do is use elimination, and I think that's what I'm going to do. Because if we multiply, we can use elimination very easily. I'm going to take this equation right here, and I'm going to multiply everything times negative 0.05. And when I do that, I get negative 0.05x minus 0.05y equals minus 1, which would be $1 right here. Now my x's cancel out. 10 cents minus 5 cents is 5.05y, and $1.55 minus $1 is 55 cents. So now we divide by 5 cents on each side, and you find out y equals 11 dimes. And since I know there's 11 dimes, x plus 11 equals 20. We subtract 11, and we get x equals 9 nickels. So 9 and 11. So I used elimination. It's really easy to use elimination when you have an x by itself and a y by itself, because when you multiply, it just, becomes whatever it is you're multiplying by. You're just multiplying by 1 on both of these. So that's pretty simple. That's my thought on it, but you may have liked to use substitution. It's fine. Do what you like. Do what works best for you. Okay, the perimeter of Aaron's rectangular tomato garden is 72 feet. The length is 4 more than 3 times the width. Find the length and the width of the garden. So here's our garden. Always draw a rectangle. And we've talked about this in class. For perimeter problems, we're always going to say 2L plus 2W equals the perimeter, 72. Now, we want to figure out the relationship between the width and the length. So the length is 4 more than 3 times the width. So the width has to be W, and the length is going to be 3 times the width plus 4. So that's 4 more than 3 times the width. And we'll do that on both of these. Now, I want you to just look at this rectangle here. Well, actually, let's go ahead and write our equation. L equals 3W plus 4. And what do you think is the easiest way to solve this one? Well, I think that would be substitution, because we already have L equals, and all we have to do is plug that in for L in this equation. So I'm going to do 2 times 3W plus 4 plus 2W equals 72. Now let's distribute, and I get 6W plus 4 plus 2W equals 72, and that's 8W plus, oh no, wait, I did 2 times 4, should be 8. 8W plus 8, sorry about that, equals 72. Now I want to stop right there, and let's go over here to our rectangle. And we have a W, we have a W. Remember, the length is 3W plus 4, 3W plus 4. Let's add those all up. And when we add those all up, we get 8W plus 8. Bam! Look, it's right there. So quite frankly, without substituting, if you had just added up your four sides, you could just jump to this step and forget about substituting, which would be fine. Again, there's always more than one way to do things. So look at that. Those are the same. Okay, but let's go ahead and finish solving. Subtract 8, and we get 8w equals 64. And so divide by 8, and you get w equals 8. So the width is 8, and so to find the length, you're going to do 3 times w plus 4. So that means 3 times 8 plus 4. And that's 24 plus 4. So the length is 24. And in this case, it's feet, because that's what we have in our problem. So we have 8, 24. This is the width, this is the length, and it is feet. Bam! Okay, let's do the last one. Felix has a bug collection consisting of beetles and spiders. He has 75 bugs in all. Although they have, altogether, they have 526 legs. How many beetles and how many spiders are there in this collection? Hint, beetles have 6 legs and spiders have 8 legs. Okay, so here's our question. How many beetles and how many spiders? That's going to help us do our let statement. So we're going to let x equal beetles, the number of beetles, and we're going to let y equal the number of spiders. So let's write two equations. So let's look at our question. One of the equations is going to deal with the total number of bugs, and the other one's going to deal with the number of legs. Okay, so total number of bugs. Well, if x is the number of beetles and y is the number of spiders, then x plus y equals 75. Now, to do the number of legs, we're going to have to multiply by however many legs they have. So 6 times the number of beetles plus 8 times the number of spiders is going to equal 526. Now let's look over these two equations and ask, what would be the easiest way for you to solve this to get a solution? And really, again, it's totally up to you. On these two, it might be fairly easy to just solve for y, and you could use your calculator. It would be easy to solve for either x or y in the first equation and use substitution. But I'm a big fan of elimination. I'm going to take this equation right here, and I'm going to multiply it times -6. Now the reason I chose -6 was 6 is the smaller of the two numbers over here. So I like to deal with the small one. And since these both have 1s, 1x and 1y, it's really easy to multiply. So -6 times 1x is -6x. -6 times 1y is -6y. And then -6 times 75 is -450. Now I'm going to combine the two equations. This becomes really easy. 2y equals 76. Divide by 2, and y equals 38. And now I can use my original equation. X plus y equals 75. So we're going to plug in 38 for y. X plus 38 equals 75. Subtract 38. And you get x equals 37. So there we go. We've solved it. We have 37 beetles and 38 spiders. And if we wanted to write that as a coordinate pair, 37, 38. Bam! There we go. And we're done. So I hope that helps. You know, just look over your equations and figure out the way that works the best for you. And good luck on all your problems. Bye!